So we'll start with working backwards. We know that when we take the derivative of our position, we're going to get our velocity. And if we take the derivative of our velocity, we are going to get our acceleration. Okay? So, what if I have the velocity function and I want the position? Antiderivative. So if I want the position, I needed to take the antiderivative of velocity. If I want the velocity and I have the acceleration, antiderivative. Okay? The antiderivative of acceleration is velocity. Okay. Okay. Now, when we take the antiderivative, we always have that plus c constant if there are no limits of integration. So if we want the actual position function from velocity, we're going to have some initial conditions. Okay, we're going to have to know at least something about where our position is at a certain time. Okay. So, first example. We want the position when we have a velocity of cosine of pi t, and we know that the position is 4 at t equals 0. Okay, we have to know at least something about our position to actually get the entire position function. So to get our position, we are going to have to do what with the velocity? Alright, this is the practice one. First of all, what's the antiderivative of cosine? Positive or negative? Good. Now I have a constant in front of my t inside, so how do I count for that? What? I couldn't hear it. We put it out in front. We divide it out in front, right? Because when we take the derivative to get back to here, we have to multiply by that. Okay? But we have this plus c. How do we find the plus c? Okay, we have our initial conditions. So our position is 4. And our time is 0. What? Okay. What's the sign of 0? Huh? What's the sign of 0? Oh my gosh. I can't ask that only 2 people mumble a 0. What's the sign of 0? Oh, you guys have known this. So c is 4. Therefore, our position function is this. Okay? Something we've done before, we're just applying it to our motion. Okay? Alright? Let's do a little bit more work. Now we have the acceleration function, and I want to get to my position. So we're going to have to do this how many times? Twice. Okay. time, first thing we're going to have to get to is the velocity function. So our velocity is the antiderivative of acceleration. T cubed plus t squared plus c. You agree? All right. So now we need c. So we'll use this initial condition right here. What does this mean? V of 3 equals 2. When t is 3, our velocity is 2. So our velocity is 2, and our time is 3. What does that make our constant? Negative 34. So we have 27 and 9. Yep. Okay, so our velocity function is t cubed plus t squared minus 34. Right. Now we need to get to position. So our position is the antiderivative of velocity. Antiderivative of t cubed. Or t squared. And negative 34. Oh, thank you. We cannot forget that plus c. What? Oh, thank you. Alright. Talking and writing is something. Alright, so our initial condition. When t is 3, our position is 8. So our position is 8. When t is 3. Alright, probably want your calculators for that one. I do want this as a fraction though. Do you have it? Go ahead and Paul do it for you. Do you have it? 62 3/4. Which, if it's as an improper fraction, is it that? Do you know how to change it to improper fraction? Close enough, or it is. Okay, if you left it as a mixed number, I mean, it'd be okay, but it would not be my preference. problems should be simple enough. It's going to be good practice for your integration because it's been a couple weeks since we've actually integrated by hand. These, you don't have a choice to use your calculator, do you? Okay. Let's move on to distance versus displacement. Okay. Displacement. Okay. Do you use displacement in physics?
Yes.
Okay. How do you define it in physics? Where you are from the origin, right? Okay. So if we're talking about displacement over time, where are we from the origin after a certain amount of time? Okay, remember we're just moving left, right, or up, down, okay? So after 5 seconds, what's our displacement? Where are we from origin? Okay. Okay. Negative displacement means what? You'd be to the left of the origin. Positive?
Right.
You are to the right. And 0? You are back to the origin. You are back to your original position. Okay? How can we find displacement over a certain amount of time? And what would you do with that graph?
Look at your last point in time.
What if we have our velocity? How do we go from velocity to position? We integrate, right? So if we take our velocity graph and we integrate it, find the area under the curve, okay, integrate it, we will know what our total displacement is.
So is that like a forward thing? Is that what it is?
So if this is our velocity, we add these together and it's what? 4. So we are 4, it's positive, so it'd be to the right of the origin. Yes, because when we integrate velocity, we get back to position. That position, if we have the position curve, we can simply look at the position, right? But if we have velocity, if we know nothing else, we'd have to integrate over time to figure out how far we've gone. Remember, when we integrate, integration means we're finding the area between our curve and the x-axis. Okay? So when we're finding the area under our velocity curve, it's the same thing as integrating. When we integrate velocity, we get back to position. Okay? For example, okay, I have our velocity equation, t squared minus 2t, and we know the units. Okay, so t squared minus 2t, right? And we want it over the time period from 0 to 3. So our displacement is simply the integral from t squared minus 2t dt from 0 to 3. Okay? We don't need our calculators to integrate this one, do we? Oh. Antiderivative of t squared. 1/3 t cubed. 2t. T squared. From 0 to 3. So I plug in 3. 1/3 times 27 minus 9 minus plug in 0. at 0 meters, which means what? We are at the origin after 3 seconds. Okay. Now we're going to talk about distance traveled. Okay. If we have a particle that moves 100 meters and then returns to the original position, it has a displacement of 0, but it has not traveled 0 meters. How far has it traveled? It's traveled 200 meters. Okay. How are we going to determine the difference between displacement and distance as far as finding it? What did you say? Absolute value of? Perfect. Okay? To find the total distance, we need to integrate the absolute value of the velocity. Exactly what Zach just said. Okay. When we find displacement, when we have, positive, negative area, they're going to cancel out. All right. So when we take the absolute value, we're accounting for the total distance traveled. Okay, we're moving everything above the x-axis. Okay. So what's going to be important if we're going to find the absolute value, the integral of the absolute value of velocity, what's going to be important about our velocity function? We go to do this. We want everything to be positive, right? So what are we going to have to look for? Where we're not positive, right? Anything that's not positive, we're going to have to make positive, right? Okay. So what we need to do, we need to figure out the intervals our velocity is negative. Okay? The intervals where our velocity is negative means we are under the x-axis, right? And what do we know about area under the x-axis? It's negative, but we don't want negative area. Okay, we want it to be positive. So if we can break up our velocity equation into intervals where we have positive versus negative area, we can adjust that sign as needed. Okay, any intervals we know are going to have negative area, we can force them to be positive by subtracting the negative area instead of adding the negative area. Are there any questions? Okay. I want the total distance traveled. We're working with the same function as we did in our previous example. We found the displacement. Our displacement was what? 0. Now we want the distance, okay? So we need to know where is our velocity positive, where is it negative? What do I need to find to help me out with that? Where is it 0? 0 and 2, right? So we have an interval from 0 to 3. It's 0 at 0 and at 2. So let's see, if we plug in 1, do we have a positive or negative velocity? We plug in 2.5, is it positive or negative?
Positive.
Very positive.
Positive.
That's a pretty quick calculation. Okay. So from 0 to 2, we have negative area when we integrate, correct? So if I want our distance, okay? When I integrate from 0 to 2 of t squared minus 2t dt, that's going to give me negative area. I want it positive, so I'm going to put a negative out in front. That's going to force it to be positive. And then we're going to add it to the integral from 2 to 3. Okay? So pause. 1, 2, and 3, you're in charge of the first integral. 4, 5, and 6, you're in charge of the second integral. I know.
Positive.
All right, plot 2, do you have something for the first one? 4/3? Plots 1 and 3, do you agree? So we have positive 4/3 plus okay, in this case, we probably have symmetry, right? Is it 4/3? Because we had to get back to the origin, right? This isn't always going to happen. Don't assume that. Okay, this is a very special case. So 8/3, we label it meters. Like I said, do not forget labels. You will be docked points on my test and the AP test. Okay. Okay, now we're not going to do this example. We're just going to talk about it because there's going to be some of these on your worksheet today. Here I'm asking for the total distance and displacement, and I give you the position function. To find distance and displacement, what do we need? We integrate the velocity function. So on these problems, you would need the velocity function first. Okay. Well, because you're talking about over an interval, right? And so you're taking the antiderivative over an interval. You're not taking the antiderivative right at any time. Okay, it's over a specific interval. Okay, so yes, it seems counterintuitive, but you need to take the derivative so you can take the integral. Okay, now you have to earn your worksheet today, though. All right, we have lots of time left in class. I have a problem right here. Everyone gets the homework, okay? But to get your worksheet, you need to do this problem and get it right. I will check it over and give you your worksheet, okay? I want to make sure you understand how to do this before I give you an entire worksheet and you practice it wrong. Okay? Everyone will get a worksheet by the end of it.
It's like that all or nothing scratch game.
For the Iowa lottery.
Right.